You open your eyes. The sky is the wrong color. Not orange, not black. Pink. A soft, dusty pink, like the inside of a shell, like the sky just before sunrise on a clear winter morning. You sit up. The ground beneath you is red, dark red, almost brown, the color of old rust, flat rocks, fine dust, a landscape that stretches out in every direction with a kind of familiar emptiness, like a desert you have not been to, but recognize anyway. You breathe in, the air moves into your lungs, and nothing happens. There is no pain, no burning, no weight pressing back against you. The air simply enters your body, as air has always entered your body, and your lungs do what they always do, and your body waits for oxygen. The oxygen does not come. There is almost no oxygen here. The air of Mars is 95% carbon dioxide. The remaining 5% is mostly nitrogen and argon. Oxygen makes up less than 1%. One breath on Mars gives your body almost nothing it needs. Your lungs are full. Your blood is empty. You breathe again, faster, again, faster still. The sky is pink and the ground is red and your breathing is not working, and Mars looks exactly like a place you might survive. That is the first thing Mars does to you. It looks like somewhere you might be okay. Mars is the most hopeful planet in the solar system. Not because it is kind. It is not kind. But because it is the one place beyond Earth where human beings have seriously imagined living. It has seasons. It has a day that lasts 24 hours and 37 minutes, close enough to Earth's that the difference would barely register in your body. It has mountains and valleys and plains and polar ice caps. It has weather. It has a surface you can walk on without instantly dying, in the way that Venus kills you or Mercury kills you. Mars kills you slowly. This is the thing that makes Mars dangerous in a way the other planets are not. The other planets announce themselves immediately. Venus hits you with heat before you have finished your first breath. Mercury burns one side of you while freezing the other. There is no ambiguity. There is no moment where you think, perhaps I can manage this. Mars gives you that moment. Mars gives you several of those moments. Mars lets you walk around and look at things and almost believe, for stretches of time, that you are going to figure something out. That you are resourceful enough. That you are tough enough. That is what Mars does. It gives you hope. And hope, on Mars, is the most dangerous thing of all. In this story, you are on Mars. The sky is pink above you. The ground is red below you, and somewhere between the way it looks and the way it is, Mars is quietly doing what Mars does to everything that arrives here without the right equipment. You stand up. Your body feels light, lighter than it should. Mars has about 1/3 of Earth's gravity, and the difference is immediately physical. Not floating, not weightless, but a persistent lightness in every movement. When you stand, you rise a little faster than you expect. When you take a step, you travel a little further than you intend. Your first thought is, this is not as bad as I expected. This thought is Mars working on you. The air is cold. Not the extreme cold of space, not yet. In the daytime on Mars, near the equator, the temperature can reach a few degrees above zero, sometimes higher. On a good day, in a sheltered spot, in the afternoon, it can feel almost mild, almost like a cold day at home. The kind of cold you would walk through without a heavy coat if you had to. You look around. The landscape is extraordinary. Red rocks everywhere. Not painted red, not symbolically red, actually red. The color coming from iron oxide in the soil, rust on a planetary scale, and the entire surface of Mars stained by billions of years of oxidation. The rocks are smooth in some places and jagged in others. Some are small, pebble-sized. Others are large boulders, worn by the same wind that is carrying fine dust past your legs right now. The dust moves slowly. It is very fine. It coats everything. You look at your hands, already dusted red. You look at the sky. The pink up there comes from the dust, too. Tiny particles of iron-rich dust suspended in the thin atmosphere, catching the sunlight and scattering it into this soft pink that covers everything from horizon to horizon. It is beautiful. That is the honest word for it. The Martian sky, on a clear morning with the sun still low and the dust hanging and the pink light falling on red rocks, is genuinely beautiful. But your breathing is wrong. You are breathing quickly now, 8 or 10 breaths where 2 or 3 should be enough. Your body is chasing oxygen that each breath delivers only in traces. Your lungs are working hard and achieving little. The feeling is the feeling of having run a long distance. The feeling of your body sending the same message over and over. More, faster, again. You breathe more slowly on purpose. Deep and slow and deliberate. It helps slightly. Slightly is not enough. There is a word for what is happening to you. Hypoxia, the condition of having too little oxygen in the blood. It begins with a feeling that is almost pleasant, a lightness in the head, a slight distance between you and your thoughts, as if your thoughts are happening in the next room rather than inside you. Athletes sometimes feel it at high altitude and describe it as a kind of euphoria before the body starts to fail. You will have the euphoria. Then, you will have what comes after the euphoria. The sun rises over the horizon and you watch it come. On Earth, the sunrise is a gradual brightening, a slow warming of the sky before the sun itself appears. Here it is more abrupt. The sky goes from dark pink to bright pink to the pale rust-colored blue of full Martian day in what feels like minutes. The atmosphere is too thin to hold the light the way Earth's atmosphere holds it. There is no long lingering dawn. The sun appears above the horizon. It is smaller than you are used to. Mars is farther from the sun than Earth is. The sun from here is only about 2/3 the size it appears from Earth. It is still bright, still sharp, still the same sun, but smaller. You can look at it more easily than you can on Earth. And the extra distance reducing the intensity, just enough that your eyes can hold it for a second, before they have to look away. You feel the warmth when it clears the horizon. Actual warmth. On your face, on your hands. The specific physical sensation of solar radiation, reaching your skin after the cold of the night. Your first instinct is relief. Your body responds to warmth the way bodies always respond to warmth, with a loosening. A gratitude, the biological memory of millions of years of warmth, meaning safety. The warmth is real, but the warmth is also a problem. The sun brings warmth, and the sun brings radiation. On Earth, the atmosphere absorbs most of the harmful radiation from the sun before it reaches the surface. The ozone layer alone blocks the ultraviolet light that damages living tissue. Mars has no ozone layer. Mars barely has an atmosphere. The sunlight that reaches the Martian surface carries the full force of the sun's radiation output. Unfiltered, direct, landing on your skin with an intensity that a summer day on Earth does not match. You cannot feel radiation. This is the problem with radiation. It is silent. It is invisible. It does not hurt when it arrives. It simply does what it does to the cells it passes through, and your body does not know it is happening until the damage is already done. You tilt your face up toward the sun anyway. The warmth feels good. You let it feel good. At night on Mars, the temperature will drop to -100 degrees. Right now, in the morning sun, it is a few degrees above zero. That range, from morning to night, is larger than the range of temperature across an entire year in most places on Earth. Your body knows how to handle a cold day. Your body does not know how to handle a 100-degree temperature swing in 12 hours, with no shelter and no insulation and no way to hold warmth when the sun goes down. Mars is quiet, not the total silence of Mercury, where there is nothing to carry sound at all. Mars has an atmosphere, thin as it is, and sound can travel through it. But the atmosphere is so sparse that sounds arrive at your ears changed, quieter, flattened. The high frequencies disappear first, absorbed or scattered by the thin air before they reach you. What is left is low, soft, muffled. The wind makes a sound. It is not the sound of wind on Earth. On Earth, wind has body. Wind pushes against you. Wind catches in your ears and makes that familiar rushing sound of air moving against air. Yet here the wind is very light on your skin, because the air is too thin to exert much force, even at speed. But the sound of it is strange. A low whisper, barely there, the specific sound of almost nothing moving. You listen to it. You stand in the Martian morning, and you listen to the wind that barely exists, and you hear the quiet of a planet that has been this quiet for billions of years. There is no water on the surface. No rivers, no oceans, no rain falling on rock. Mars had all of these once. Ancient Mars was wet. The evidence is everywhere in the landscape, if you know how to read it. Dry riverbeds carved into the rock. Minerals that only form in the presence of water. The round, smooth shape of rocks that were tumbled by a current a long, long time ago. The water is gone now, most of it locked in ice beneath the surface, as some of it frozen at the poles. A little suspended in the atmosphere as vapor. The liquid water that carved these valleys has not flowed here for hundreds of millions of years. Mars is a memory of a wetter place. You walk across the floor of what was once, perhaps, a shallow lake. Beneath your feet, a few meters down, there may be ice. You cannot reach it. The silence continues. The dust is inside your nose now. You breathe it in with every breath. Fine red, iron-rich dust. The same dust that colors the sky and the rocks, and now your hands and your clothes, entering your lungs along with the thin carbon dioxide air. It is not sharp like Mercury's dust. It is very fine, very small, the kind of particle that goes deep into the lungs and stays there. Your lungs are doing three things at once now, searching for oxygen, pushing out carbon dioxide, and receiving dust. None of these three things is going well. You walk. You walk because you are still looking for something. Shelter, higher ground, a different view, a reason to keep moving. You are not sure which of these you are actually looking for. The walking itself feels like the point. As long as you are walking, you are doing something, and doing something is different from accepting the situation, and you are not ready to accept the situation. The terrain changes slowly. The flat, dusty plain gives way to a field of larger rocks, boulders some of them, dark and pitted with the texture of material that has been sitting in the cold and the radiation for a very long time. You move through them. Your steps are careful but light, the low gravity making each footfall a small decision, each step landing softly on the red ground. You find a crater, not a large one, perhaps 50 meters across and 10 meters deep. The walls slope inward at a manageable angle. You stand at the rim and look down into it. The bottom is smoother than the surface around you. The crater has collected fine dust over the years, filling in its own floor, creating a flat, pale red surface inside. The walls provide some shelter from the wind. The sun, still low, sends light into the crater at an angle that illuminates the far wall in a way that is almost warm-looking. You go down into it. The descent is easy in the low gravity. You find footholds in the crater wall without difficulty. At the bottom you stop and look up. The rim of the crater frames the sky, a circle of pink sky, the sun just visible at one edge of the circle. The crater walls dropping down to the flat floor where you are standing. But from here, you cannot see the flat plain in any direction. You cannot see the horizon. You can only see the inside of this bowl and the sky above it. It is quieter inside the crater. The wind, what little there was, does not reach the bottom. You sit down on the fine dust of the crater floor. You breathe carefully, slowly, trying to get the most from each breath. The crater is not shelter in any meaningful sense. The temperature inside it is the same as outside it. The radiation reaches the bottom as easily as the surface. The dust inside it is the same dust, but it is enclosed. It has walls. It feels like a place rather than an expanse, and a place right now is something. Your head is doing something strange. The lightness that started with the first breath has grown. Your thoughts are clear, but they are clear in the way that thoughts are clear when you are very tired, or when you have been at high altitude for too long. Each thought arrives fully formed and then drifts. You cannot quite hold the thread from one thought to the next. This is the oxygen leaving your blood. This is your brain beginning to make small economies, conserving what it has, rationing function. You notice it happening. You can observe it. You are not afraid of it, which is itself a symptom. You see the horizon darken first. To the north, the pink sky is getting darker. Not darker the way sky gets dark at night, gradually and evenly. Darker in a specific direction. A wall of something moving toward you across the plain. You stand at the rim of the crater, and you watch it come. It is a dust storm. Mars has some of the largest dust storms in the solar system. They can grow until they cover the entire planet. They can last for months. The individual dust particles are tiny, and the winds that carry them are not extraordinarily fast by Earth standards. But there is nothing on the Martian surface to stop them. No trees, no buildings, no terrain that breaks the wind into smaller pieces. The storms move across the planet the way nothing on Earth moves, unstoppable and total. You watch it come. And the leading edge of it is visible now as a brown-red wall that fills the northern horizon completely. It is moving quickly. You can see the rocks on the plain in front of it disappearing as the dust reaches them and swallows them. The sky above the storm is dark. Not night dark, but storm dark. A deep orange-brown that blocks the sun and turns the world the color of old iron. The wind reaches you before the main wall does. The wind of a Martian dust storm. On Earth, a wind this speed would be noticeable, but not alarming. But this wind is carrying dust that is very fine and very numerous, and it arrives at your face and your hands and every exposed part of you like a very gentle sandpaper. You close your eyes. You raise your arm against your face. The dust gets through anyway. The temperature drops quickly. The dust blocks the sunlight, and the sunlight was keeping the surface temperature above zero. And without the sunlight, the surface of Mars returns to what it defaults to, which is cold. The cold arrives along with the dark and the dust and the sound, which has changed from the near silence of the clear morning to something that is still quiet by Earth standards, but is the loudest thing you have heard since you woke up. The storm reaches you. You get back down into the crater. Inside the crater, the storm is a sound above you, and a reddening of the sky above the rim, and a constant light rain of dust settling down from above. The storm is not dangerous to you, in the way a storm is dangerous on Earth. The wind will not knock you over. The lightning, if there is any, is weak. What the storm does is take the sun away. And without the sun, Mars, at midday, feels like Mars in deep winter, and Mars in deep winter is cold enough to freeze carbon dioxide out of the air itself. The temperature falls, and keeps falling. The temperature on Mars falls fast when the sun goes away. On Earth, clouds and atmosphere hold warmth. They act as insulation, keeping heat close to the surface, even when the sun is blocked. Mars has no such insulation. The thin atmosphere holds almost nothing. When the sun is blocked, the warmth it was providing simply stops. The surface loses heat immediately, radiating it outward into space with nothing to slow it down. You feel it begin. The cold of Venus was the cold of something pressing inward from everywhere. This is different. This is the cold of heat leaving, specifically leaving. Yet your body has warmth in it, and the warmth is moving outward through your skin and into the thin, cold air of Mars, and nothing is replacing it. You pull your arms in against your body. You make yourself smaller. This is what bodies do in cold. They try to reduce surface area. They pull resources inward toward the core. They make the calculation that the core is worth protecting at the cost of the extremities. Your feet are already cold. Your hands are cold. Your face is cold. The exposed skin has been giving heat to Mars since you arrived, and Mars has been accepting it without comment. The dust is still falling. Fine red dust settling on you and around you and onto the crater floor, covering everything in a thin, even layer. If you stayed here long enough, if you sat still long enough, the dust would cover you too, slowly, as a little at a time. Mars would simply accumulate on top of you the way it accumulates on everything, the patient process of a planet that has been doing this for billions of years. You do not sit still. You stand up and move around the crater floor. Small circles, your footsteps in the dust, keeping the blood moving, keeping the warmth, what is left of it, circulating. The circles get smaller. Not a decision. Your body making the circles smaller because making larger circles costs more than it has available right now. You think about what is underground here. A few meters down there is ice. Scientists know this. Probes have detected it. Beneath the red dust, beneath the rocks, there is frozen water. And the ancient water that used to flow on the surface of this planet. Before the atmosphere thinned and the warmth left, and everything that was liquid became solid and stayed that way for hundreds of millions of years. The water is so close. You could reach it with the right tools. You do not have the right tools. You do not have any tools. You have yourself, and what you are carrying, and what you are carrying is not enough. The storm passes, not quickly. Storms on Mars do not pass quickly, but after several hours, the darkness above the crater rim begins to lighten. The brown-red of the storm sky fades back toward the pink-orange of clear air. The dust in the crater settles. The wind above decreases, and then the sun comes back. When the sun returns to the Martian sky, it does not come back gradually the way it comes back on Earth after a storm. It comes back all at once. One moment the sky is storm dark, and then the dust thins enough and the sky becomes itself again and the sun is there, small and sharp and brilliant in the thin pink air. The warmth arrives. You feel it on your face, and you turn toward it, and the relief of it is physical and immediate and real. That the sun of Mars is smaller than Earth's sun, but it is still a sun, and it still produces warmth, and after the cold of the storm, the warmth is everything. Your body responds gratefully. This is the moment that Mars was waiting for. The moment when you feel the warmth and you think, I can do this. It passed. The storm passed and the sun is back and the temperature is rising and I am still here and I can do this. This thought, this specific thought, this is the most dangerous thing that has happened to you on Mars, because you cannot do this. The sun will set in a few hours. The temperature will drop to -100. The oxygen shortage that has been building in your blood all day does not get better when the sun comes out. Your body's resources, the warmth and the food and the water that it runs on, have been depleting since the moment you arrived, and the sun coming out does not refill them. But you feel hope. You feel it clearly, warm, specific, physical hope. The kind that arrives in the body before it arrives in the mind. And you stand in the returning sunlight with your eyes closed and your face turned up, and you let yourself feel it. This is what Mars does that no other planet in this series does. It gives you something real to feel good about. The warmth is real. The sun is real. The beauty of the afternoon light on these red rocks is real. Mars is not tricking you with false comfort. The comfort is genuine. What Mars is not telling you is that genuine comfort and survival are not the same thing. You can be genuinely warm and genuinely dying at the same time. Mars knows this. Mars has known this for billions of years. And the sun moves toward the horizon. You watch it go. On Earth, sunsets are red and orange and gold. The light passes through more atmosphere as the sun gets lower, and the atmosphere scatters the shorter blue wavelengths away and lets the longer red and orange ones reach your eyes. The colors of an Earth sunset are the colors of thick atmosphere. On Mars, the sunset is blue, not a vivid blue, a soft, pale blue, almost gray blue, spreading out around the sun as it drops. The fine dust in the thin air, scattering light in a way that is the opposite of Earth's effect, letting the blue through where Earth would keep the red. The sun sets into a blue glow on Mars. The horizon turns blue. The sky near the horizon is blue-gray, while the sky high above is still the rust-orange of the afternoon. You have never seen anything like it. Yet the specific beauty of it stops your thoughts completely for a moment. Blue on red, the blue of the sunset light falling on the red of the rocks reflecting it back as something purple, something that has no good name. The color that happens when the blue light of a Martian sunset falls on iron-red rock on the floor of an ancient crater. You sit down to watch it. Your breathing is slow, slower than before, not controlled slow, simply slow, the pace of breathing settling into a pace that your body has decided on without asking you, a pace that matches what is available. The sun reaches the horizon. It does not linger. The thin atmosphere does not hold it the way Earth's atmosphere holds the last light of a sunset, stretching it into long minutes of color. Here, the sun touches the horizon and keeps going, and the light drops quickly. The blue fades, the sky darkens, and the cold begins again. This time, the real cold, the nighttime cold, the cold that has no bottom until it reaches -100 and will not stop before it gets there. The stars come out above Mars and they are magnificent. Not the same as Mercury's stars, which were overwhelming in their intensity against a perfect vacuum sky. These stars come out gradually as the sky darkens, appearing one by one and then in groups and then all at once, thousands of them. The full night sky of the inner solar system, seen through a thin layer of dust-tinged atmosphere. You can see the Milky Way. You can see it from Mars in a way that is barely possible from Earth anymore, from anywhere with electric light nearby. The Milky Way above Mars is the Milky Way without interference. The night cold is different from the day cold. The day cold was manageable, uncomfortable, a problem. The night cold is in a different category. It is the temperature of a place that has no insulation between the surface and space. A place where heat leaves the moment the sun goes and does not come back. -80 degrees, -90, the temperature dropping steadily, predictably, following the same curve it has followed on every Martian night since the atmosphere thinned and the planet lost its warmth. You know this temperature is coming. You have known since late afternoon that it was coming. Knowing did not help. Your body is doing everything it knows how to do. Your muscles are shivering, generating heat through movement the way muscles do when there is no other option. Shivering is expensive, as it burns energy that your body does not have to spare and produces heat that the cold takes immediately. The math of shivering on Mars is unfavorable. You are spending more than you are gaining, but the shivering continues because the shivering is not a decision. The shivering is the body doing its last automatic things. You look at the stars. They are very still, very bright. The small Martian moons are up there somewhere, Phobos and Deimos. Phobos moves fast enough that it rises in the west and sets in the east, moving in the opposite direction from the stars. You watch for it. You think you see it. A point of light moving slightly faster than the others, tracking across the sky. The tiny moon that is gradually spiraling closer to Mars and will eventually crash into the surface or break apart into a ring. Not tonight. You watch it move. Your shivering has slowed. This is not improvement. When shivering slows, it means the body has stopped being able to afford it. The muscles have run out of what shivering requires, and they have gone quiet. And the quiet is not warmth, but exhaustion. The body finding its way to stillness. not because it is comfortable, but because stillness is all that is left. There is a rover on Mars. Not nearby, not within walking distance, but somewhere on this planet there is a machine built by people on Earth and sent here to understand this place. It is sitting somewhere on the Martian surface right now, in the cold, as you are sitting in the cold. The rover does not experience the cold. It was built for it. It waits out the night in low power mode, and when the sun comes up, its solar panels wake it and it continues its work. And it has been doing this for years. It does not hope. It does not feel the temperature fall. It simply waits for the sun. You are not a rover. The cold is very deep now, past the point of shivering, past the point of the body making active decisions about how to respond. The cold has gone through the outer layers and the inner layers and is now in conversation with the core, which has been defending itself for hours and is running low on what defense requires. You are lying on the crater floor. You do not remember lying down. It happened gradually, the sitting becoming leaning and the leaning becoming lying. The body finding its lowest energy state, the way water finds its lowest level. The dust is fine beneath your cheek, cool and fine and red. You look sideways across the crater floor. From this angle, the dust has a texture. Small ripples where the wind has moved it over time. The same patterns wine makes in sand on Earth. And the same mathematics of fluid dynamics applied to this different medium, in this different place. The universe using the same rules everywhere. Wind and dust make the same shapes on Mars that they make in deserts on Earth. The patterns are the same. Only the color is different. The stars above the crater rim are brilliant. You watch them. You have been watching things all day. The pink sky at sunrise. The red rocks in the morning light. The dust storm arriving. The sun returning, the blue of the sunset. The stars coming out. Mars has given you things to look at all day long. That is true. The planet is visually extraordinary. The specific combination of red and pink and the clarity of the stars and the blue sunsets and the ancient landscape. These things are real and they are worth looking at. Mars did not owe you any of it. Mars does not owe you anything, but it gave you the sky. All day, the sky. The breathing is very shallow now. The breaths are small and far apart, and each one is a small act of continuation. The body finding the molecules of oxygen in the thin Martian air and extracting what it can, which is less than it needs, which has been less than it needs since the first breath this morning. You are not in pain. This is the thing about hypoxia at this stage. The oxygen has been leaving the blood for hours and the brain adapts quietly without alarm. And what is left is a clarity that is almost pleasant, a distance, a sense of the whole day arranged in front of you, all of it visible at once, the morning and the crater and the storm and the afternoon warmth and the sunset and the stars. All of it real, all of it yours. You thought, when the sun came back after the storm, that you could do this, that you were tough enough, or resourceful enough, or that something would change. You were not wrong to think it. The hope was real. The warmth was real. The beauty of the afternoon was real. None of those things were lies. They were Mars being what Mars is, which is a place that looks survivable until the sun goes down and keeps looking survivable right up until it becomes clear that looking survivable and being survivable are different things. Mars has been fooling better-equipped visitors than you for a long time. Rovers and probes and spacecraft. It looks almost like home. It is not home. It has never been home. But you were here. That is not nothing. The stars above the crater rim do not move. That is not true. They move the way all stars move. The slow turning of the sky as Mars rotates. But the rotation takes 24 hours and 37 minutes, and you cannot see it happening. The stars appear fixed, permanent. The same stars that are above Earth right now, above Venus, above Mercury. The same stars from everywhere in the inner solar system, because the inner solar system is very small compared to the distance to the stars. You see, Earth, a small blue point of light near the horizon. Not obviously blue. You have to know what you are looking for, but there it is, in the right part of the sky, the right brightness, moving in the right way. A small pale dot, the same pale dot that Carl Sagan described when Voyager turned around to photograph it from the edge of the solar system. And a mote of dust suspended in a sunbeam. You look at it. Everyone you have ever known is on that dot. Everyone who has ever lived. Every city and every ocean and every mountain and every quiet room where someone is sleeping right now, warm under blankets, breathing air that is thick with oxygen. You look at it for a long time. The cold is past feeling now. The breathing is past counting. The stars are very bright. The crater is very still. The dust of Mars is the same color as rust, the same color as old blood, the same color as the sky at the beginning when you opened your eyes this morning and thought, this is not as bad as I expected. It was worse. It was also better. It was Mars. Close your eyes. The sky was pink this morning. The sunset was blue. The stars are very old. Earth is that small blue dot. You were here. A note of science. Mars is the fourth planet from the Sun and the most studied planet in the solar system after Earth. Dozens of spacecraft have been sent to Mars. Several rovers are currently operating on its surface. It is the only planet other than Earth on which human-made machines have driven around. The Martian atmosphere is 95% carbon dioxide, with less than 0.2% oxygen. At sea level on Earth, the air is roughly 21% oxygen. The atmospheric pressure on Mars is less than 1% of Earth's. This means a human being on the Martian surface would lose consciousness from lack of oxygen within minutes, without any other factors involved. Surface temperatures on Mars range from about 20 degrees Celsius on a warm summer afternoon near the equator to negative 125 degrees Celsius at the poles in winter. And the average surface temperature is approximately negative 60 degrees Celsius. The temperature swings are extreme because the thin atmosphere holds almost no heat. Martian dust storms can cover the entire planet and last for months. During the 2018 global dust storm, NASA's Opportunity rover, which was solar-powered, lost contact with Earth when dust blocked enough sunlight to drain its batteries. It never recovered. NASA declared the mission over in February 2019, after 15 years of operation. Mars sunsets are blue. The same dust particles that make the daytime sky pink scatter blue light around the sun at sunset, reversing the effect seen on Earth. Photographs taken by Mars rovers have confirmed this. The blue Martian sunset is one of the few genuinely counterintuitive facts about the planet's appearance. Mars has two small moons, Phobos and Deimos. Phobos orbits so close and so fast that it rises in the west and sets in the east, completing an orbit in about 7.6 hours. Phobos is gradually spiraling closer to Mars. In roughly 50 million years, it will either crash into the planet or break apart and form a ring. Water ice exists on Mars, both at the poles and beneath the surface in many locations. The Mars Reconnaissance Orbiter has detected subsurface ice in large quantities at mid-latitudes. Liquid water cannot currently exist on the surface because the atmospheric pressure is too low. Below a certain pressure, water skips the liquid phase entirely and goes directly from ice to vapor. Earth, seen from Mars, is a small bright point of light in the Martian sky. It is visible to the naked eye. To a person standing on Mars, Earth and the Moon would appear as a pair of bright dots. Earth would be the brightest object in the Martian night sky after the Sun and the two moons. Next, Jupiter,